All right, today we're going to be talking about the area formulas. Fortunately, I think all of these formulas are on your formula sheet. So I'll give you back your ones that you left in here yesterday, but I don't want to have to keep up with them anymore. So rectangle, parallelogram, triangle, trapezoid, and circle. Trapezoid, the bases, it has two bases. The parallel lines are the bases. A height is always perpendicular to a base. So if you're trying to identify the height in a figure, you're looking for a perpendicular line. Okay? Any questions so far? All right. So here's what we got. We've got finding the area of a parallelogram. You might want to write your formula down before you start plugging stuff in. Sometimes that helps keep your thought organized. Remember, the problem will probably give you more information than you need to use. So the area of a parallelogram is base times height. And in this case, what are the two numbers that are perpendicular to each other? 5 and 4. So 5 is what I'm going to use as the base, and 4 is what I'm going to use as the height. So 5 times 4 is 20. Inches times inches gives you square inches as your unit. This is not inches squared. This is the symbology to refer to square inches, so you don't have to write out the word square inches. So the area for A is 20 square inches. Area is going to be in squared units because it's dimensions. It's base times height. Right. Once again, it's okay to have a height that doesn't necessarily exist inside your figure. But when you write the base and the height, the base is always going to be the line that was perpendicular to the height. Sometimes you might have to extend the base to see that perpendicular relationship. Like we have a base right here of 2 centimeters, but I extended this line out and extend this down so that I have a perpendicular relationship between this length right here and this length right here. So I don't use 4.6 as the base because I don't have a perpendicular line drawn to it. I do use 2 centimeters as a base because when I extend it, I have a perpendicular line drawn to it. So it's 2 centimeters times 3.5 centimeters. So 2 times 3.5 is going to be 7 square centimeters. Everybody okay with that? Let's practice. Draw this picture and find the area. So if we're going to draw a parallelogram, I'm going to sketch a parallelogram here real quick. Two parallel lines that are congruent and parallel make a parallelogram. And so the base was 12 and the height was 9. Is this legit to do? Yeah. Because these two numbers are perpendicular, that's legit, right? So that's a valid sketch, even though it's probably backwards from what you did. Area is equal to base times height. All you had to do is multiply 12 meters times 9 meters. 12 times 9 is 108 square meters. Everybody okay with that? So just doing a direct application of the formulas shouldn't be too hard. Let me caution you on the triangle formula. A lot of times people will mess up the triangle formula because they forget the 1/2. So just keep in your brain that a triangle is half of a parallelogram. Boom, look, 2 triangles. Boom, look, 2 triangles. So triangle is half of a parallelogram, it's half of a rectangle, so the formula is half of that. Okay? Keep that in your mind. All right, here's where it gets a little tricky. So what we're going to do is we're going to find the value of DE. We're going to find this height. So you might be thinking, well, that's just plugging it into the formula. Area is equal to base times height, and the base for that height would be 19.4 inches. I'm sorry, 9.4 inches, because that's what's perpendicular. The problem is, what do you put in over here? You can only have one variable to solve an equation. However, we have enough information to actually find the area of that parallelogram. We just have to use the other information we're given. So the other height is paired with the other base. So area is equal to base times height. And I know that this is a base and this is a height, but isn't this a base and this a height as well? Would you agree with that? So this will be 13 inches, and this will be 9 inches. And 13 times 9 is 117 square inches. So here's what's cool. When you put the 117 square inches over here, and you go through and you solve for h, and you divide both sides through by 9.4 inches, then your units end up working out, because height is supposed to be in inches, but inches cancel with inches, 9.4 cancels with 9.4, square inches cancel with inch, leaving an inch. And so 117 divided by 9.4, try not to break my calculator, 117 divided by 9.4 is 12.44. I'm going to round off to the nearest tenth, so that's 12.4 inches. So that's your height. There will be a problem like this on the next quiz. There will be a problem like this on the test. People miss it all the time because they forget you have to use the other information to find the area, and then you use that area to find what was missing. So it's a two-tiered, two-step problem. People miss it all the time because they forget that they've got to do 2 steps.
What does that say on the left side?
Other height, other base?
No.
On the left side.
On the left side of 9.4, like right under A, the big A.
That's 117, but it's not drawn very well. It did look like a word, didn't it?
So you just it looks like
117. How's that? All right. So, you want me to wait? Practice on this one right here. So, I'll go ahead and draw the parallelogram for you. So I'm going to draw a parallelogram. I'm going to draw a side. I think what I'll do is, to make sure that I have a really well-depicted parallelogram, is I'll duplicate this. So this is both congruent and parallel because I haven't rotated it. And then when I connect the other 2 sides, you'll definitely have a parallelogram. So I can say beyond a shadow of a doubt, this figure that I just drew is a parallelogram. All right, so the measurements here are going to be 15 and 18. So this looks like the longer one. I'll make this 18, and I'll make this 15. Oops, that's 115. That's not too high. I'll make this 15. And then the height corresponding to the 15 centimeter base is 9 centimeters. So what that means is, I'll go ahead and get me a little dotted red line.
Mr. Baker.
Maybe I won't. Oh, you're right. You're right. So that doesn't look perpendicular. That does look perpendicular, though, doesn't it? So there's the height according to the base. So that's going to be 9 centimeters. And what they're asking you for is they're asking you to find they're asking you to find that length right there.
Mr. Raker, I have a question.
Yes, ma'am.
How did you know to draw the line?
All right, so I know I need to find this height right here, and this height goes with the 18 centimeter base. Technically, this line up here is the base, but remember, in a parallelogram, opposite sides are congruent. So that's considered 18 as well. So area equal base times height. I have the 18. I'm looking for the h, so I need the a to complete the equation. So what I'm going to do is I'm going to use my other information, the 9 height and the 15 base, to find the area. And like I said, there will be one of these on the quiz. There's a couple of them on the homework. Make sure that you try to figure them out. So area is equal to base times height. So base is 15. And height is 9. And then you multiply 15 times 9 together, and you get, 135. So that's 135 square centimeters. So now over here, I'm going to solve for h by dividing both sides by 18. So 135 divided by 18 is 7.5. And your units are still centimeters, so it's going to be centimeters.
What is square?
Yeah, what's the quiz?
I don't know.
Will it be when
No.
What is it? What are you saying?
I don't know. It might be. We might have it next Friday. We'll see. No, we're off. We're off Friday.
No, let's
So
have it next Friday.
I don't know when the next quiz will be. All right. So finding the area of a triangle. So here's where they get a little bit complicated because I've given you units in feet and inches, and I need to know how many square feet of material. So this one has some conversions in it. I'm just going to go through and demo this. What's the formula for the area of a triangle? 1/2 base times height. I'm going to change the 13.4 to feet. So now technically you've got to be careful about unit conversion. So if our answer is going to be in square feet, we really need to be working in feet. So what I need to do is I need to change 13 feet 4 inches into a decimal. And I need to change 12 feet 2 inches into a decimal, or some sort of fraction that I can work with that's in terms of feet. So how many feet are in an inch?
12, so that'd be 13 or 1.
So that's 12, that's 4/12 of a foot, and that's 2/12 of a foot. So this would be 12 and 1/6 foot. This would be 13 and 3/4 feet. And I would probably go ahead and change both of those into an improper fraction.
1/4.
I'm sorry, you're right, 1/4.
1/3.
1/4. 1/3. I don't know where my simplification brain
So
is.
could you do 13.3?
So 13.3 is an estimation.
Yeah.
I'd be okay, and even this one's an estimation. So no, you just need to change it to a fraction. So Alex, how would you change this one to a fraction? Improper fraction.
13 and 1/3.
That's right. 6 times 12, which would be 72, plus 1. So that's going to be 73/6 is the height. 3 times 13 is 39, plus 1 is 40. 40/3 is the base. And now we're going to multiply everything together. So the 2 will cancel with the 40, giving me a 20. The 20 will cancel with the 6, giving me a 10 and a 3. And then, so that's 730 over 9. How many square feet of material? I'm going to round it off to the nearest square foot. So that's in square feet. 730 divided by 9 is 81.1. So I'll probably need 82 square feet of material.
I have a question.
Yes.
If you went from feet to inches and then got that inch and then converted it back to feet, would you still get the same thing?
So the tricky part about that is you'd have to double convert. And we'll,
I honestly would rather do that than deal with fractions.
okay, well, we'll talk about that. Time-wise, I don't really have time to cover that, but we'll talk about that. Right, we'll do that Tuesday. So yeah, rework this problem using inches and convert it back and see if you can get 82 square feet is the answer.
I don't know how to work fraction.
All right. What is the area of this triangle in, let's do it in feet. So area is equal to 1/2 base times height. 5 inches is how many feet?
60. Oh, wait, 5 over
5 inches is how many feet?
5/12.
5/12. So 1 times 1 times 1 is 5, 2 times 12 is 24. So the area is equal to 5/24 square feet. All right. The other thing you're going to have to be able to do is you're going to have to be able to find out the area of irregular figures. The area of irregular figures means you just break them up into what they are. So what did you have? You had a triangle that has a height of 8, and what do you think its base is? 6. And then you have a square that has a side of 6. So this is area is equal to 1/2 times base times height, which is 1/2 times 6 times 8, which is 24. And then over here, this is area is equal to base times height, or you could just say side squared. 6 times 6, 36. Then you add the two together. The 24 square inches plus the 36 square inches is going to equal 60 square inches. Does that make sense? All right, so you have until Tuesday to do your homework. See you.